looking at a triangle. That was a bad one. This is pi over 6 in here. Okay? And the reason I'm doing this is I can't figure out 5 pi over 6. We don't have any systems to figure this out. But I can figure out what pi over 6 is. That's easy. So I can figure out what pi over 6 is, and as you'll see, we'll come up with a value that's different than if I did pi over 6. So let's talk through that. So what I want to do now is talk about the similar triangles. Now I'm going to skip back to blue here. Now, if you're still having issues with your triangles, just keep referencing the page that I've given you before. And as a reminder, the reference triangle that I'm referring to is on page 185 in your book. So if I check that, I'll find that this is 1/2. So this side here is 1/2, and this distance in x is √3/2. Now that's just in terms of that standard triangle. But keep in mind, I'm moving this way, so that's negative √3/2. Okay? So now what I'm going to do is go figure this out. So cos 5 pi over 6 is going to be calculated the same as if I was just doing cos of pi over 6, right? Done the same way. So this would be the same as cos of pi over 6. Because remember, all these things are just cyclical. You keep running in a cycle. So cos theta, if I want to start solving this, let's use our general format. I have cos theta is going to be equal to x over 1. Okay? So what's my x coordinate? Well, my x coordinate here is this distance here. Right? This distance right there. And I've said that this is negative √3/2. So cos of 5 pi over 6 is equal to negative √3/2. And this is different than if I was to have done pi over 6. Right? If I did pi over 6, which would be this one here, this distance would have been √3/2. So cos of pi over 6 is positive √3/2. Cos of 5 over 6 is negative √3/2. So that's how we can tell the difference between them. I'm using the same triangle, right, a flipped triangle that we talked about in 4.2 to solve it, but you have to be aware that even though I'm working with the values for pi over 6, I'm actually solving for 5 pi over 6. So if this connection is a little confusing, just rewind the video and watch it again to hopefully connect why those are the case of what they are. So that's if I'm trying to find an exact coordinate. Okay, so the last thing we need to do is start talking about how to get inexact measurements of angles on the circle, or if you're given an angle, how to work backwards towards determining the coordinates. So let's just stick with this one that I've worked with so far, right? We went through this explanation and we know how to get this value. Now remember that in fraction form like this, this is an exact value. It is exactly negative √3/2. If I turn that into a decimal, that's going to be something different. So let's go up and take a look. So here I go, 3 root is going to be this, divided by 2 gives me 0.866. So down here, I would go write equals 0.866. Now they'll tell you usually how many decimals you want. If they don't say anything, I usually think 3 decimals is a pretty good value. Because keep in mind, the further down this line you go, the more of a guess it is on the part of your calculator. Okay, so this is all we mean by determining the inexact properties, because we want to work in decimals. Because lots of times when you're doing math, especially computer applications, engineering, things like that, we're going to need decimals, so we have an actual thing we can measure on some kind of a device. Last time I looked, there's no protractor or anything that has root 3 over 2 on it. Okay, so let's go talk about now how can we do some of this. So this is in page 196 on your book, and they're talking about how to take inexact measures. So 1a here is talking about the same thing as before. Tan of 7 pi over 5 would be, you take 7 times pi divided by 5, take tan of that value, and you get what's the case. So let's take a look at what do we mean there. So tan of 7 pi over 5. So first things first, we need to figure out what's 7 pi over 5. So just like we were doing before, I need to find my pi value on my calculator. Mine's here, yours will be somewhere else. Pi times 7 equals some number divided by 5 is going to give me So that's going to give me 4.398. Okay, I'm just approximating that value. So this is going to wind up being tan of 4.398, which is going to be equal to some value. I'll use a calculator to figure out. Now, before I go do this, is a very important step. Here's the first time it's going to happen from what we've talked about before. This calculator right now is telling me that I am in degrees. Okay, I'm operating in degrees. But because I was working in terms of pi, that means all these numbers, 4.39 and all this, are all in radians. So I need to switch to radians. So on mine, I click a little radian button, and it switches to radians, so I know that that's what I'm working in. Now I can take tan of this value, tan, and it gives me 3.078. Okay, so that's how we're going to get that value, and that's the same as what they got over here in the book. And note they're using a little squiggly line. So if you remember to use the squiggly lines, that'd be great. But you know, for us, it's not going to make or break the situation. That's if you're working in radians. On B for that example, right? So B now, I'm looking at this one here, still on page 196, and this was cos of 260 degrees. This is probably the one you've been used to working with in the past. So cos of 260 degrees, well, we just go do as you'd expect, we go use our calculator. But remember, I just switched this to radians, so I need to switch my calculator back to degrees, and then it's going to be 260 degrees, and then I'm going to go hit cos. But before we do that, let's think about that. Here, this is 180 degrees. This is 270 degrees, which means that this is going to be down here somewhere. Okay? So this is both a negative x and a negative y, so without even having to go back to check whether cos is x or y, I should expect a negative value to pop up here. So I should see a negative value showing up on my calculator. Let's see if my calculator knows how to calculate this correctly. So I'm just going to go ahead and hit cos, and I get negative 0.174. Okay? So this again is an inexact value. These are all the decimal formats. Those are inexact values. So the last thing we need to do here, before we move on to our homework and activities for the day, is to go look at, if I give you negative 0.174 or 3.078, how do you work back